Welcome to 1 week on magnetism, 1,000-mile view. This topic fits most nicely at the end of current electricity, but we're going to do static electricity then. After the midterm, we'll do static electricity before magnetism comes back in force, before magnetism comes back seriously. It's kind of awkward. You actually have to remember something for a bit. Sorry, not sorry. The more you learn things deeply, the better you'll do at the final. However, what I'm going to say is I have kept this intentionally I hope, a good balance of difficulty here. There are very few facts to know. There are like 3 equations to know. There is one bit that you will have to think about, and if you just ignore these classes, you're screwed. Also, the people online, I'm sorry, but this is very highly visual. This is very highly do it. If you're online, and for that matter, if you're here, I also strongly suggest that you use videos, YouTube videos, and pause them and try the stuff yourself. The right-hand rule is what's the punk when it comes to just reading about it. You can't just read about it, really. It's really easy once you get it. Really easy. It's just remembering 1, 2, 3. That's it. Okay, but enough of telling you what I'm going to tell you. Let me tell you stuff. Magnetism. We're going to do a shallow dive, not a deep dive, into a couple of phenomena. And as I said, the things to know, the conceptual stuff about this I really keep at a light level. There are only a couple things, and we're going to need, I'm giving them to you for a serious reason. We're going to go into a couple of things that you do have to think about. We'll need those pieces later. Okay, so first, magnetic fields. What is a magnetic field? Well, first off, let me tell you what a field in general is. A field is cause and effect. Oh, a field is just the cause. Everything in physics connects cause to effect. This object exerts a force on that object. This electron attracts that proton, right? That's the goal of physics, to predict how things interact and do things, right? Okay, the idea of a field, the big idea of a field is instead of talking about 2 objects, we're going to talk about 1 at a time. That's it. We're not going to say object A pushes on object B. We're going to say object A makes an invisible, intangible, and possibly imaginary field around itself. We're going to imagine that everywhere around object A, there is this thing called a field. We can calculate it, we can predict it, we can come up with a number and a direction for it. And then we say, okay, object B is in this position at this field. What force does it feel? How much energy does it have? Blah, blah, blah. Gravity is a stupidly simple example of a field. Stupidly simple, because everywhere on Earth has got the same value, 9.8 down, 9.8 towards the Earth. Yeah.
You said like the field is the cause. So what is the reason of the cause?
Well, the reason that the field is created that's not physics, that's philosophy. We can't answer why is the universe the way it is. All we can say is, here is what we observe, here's how to predict what we observe. This connects to various phenomena together, but ultimately, why does an electron make an electric field? Why does the North Pole make a magnetic field? Unanswerable. Philosophy. Go ask a religious person that. I cannot, as a physicist, answer why the universe is the way it is. Okay, so magnetic fields, the big idea I want you to have, and you need this isn't just me pontificating. I'm going to talk about electric fields, and you have to be able to separate these. A field is, we imagine just an object creates a field around it, and you need to be able to calculate and predict and understand the field an object creates. And then to get an actual force, to get an actual energy, you take an object in a field. If you know the field, you can find the force and energy it feels. It feels, not fields. Okay? So 2 parts. Find the field, find the force, or energy, or whatever. A magnetic field is created, exuded, emitted, surrounds every object, every magnet in the world. We'll talk about what makes a magnet next lecture. Every single object that is magnetic creates a magnetic field around it. It is very much analogous to how Obi-Wan describes the Jedi Force. It's not the Jedi Force, but it's like that. Does everyone know what I'm referring to? Has anyone escaped 20 years of your life without having been shown Star Wars? You have not seen Obi-Wan? Oh my goodness, you lucky punk. I mean, some people like it. Anyway, moving on before I get attacked by Star Wars fanatics. A magnetic field, let me tell you how to find the direction first. We'll talk about the magnitude tomorrow. The direction that the magnetic field points can always be determined. Here's an operational definition. Hold up a compass somewhere. Which way does it say north is? That's it. That's the direction of the magnetic field. In general, you got a bar magnet. The magnetic field points, let's see, toward or away from south poles? Which way do you think the magnetic field near a bar magnet points? Do you think it points towards north poles or towards south poles? Which way is a compass north attracted? Are opposites attracted or are sames attracted? Opposites are attracted. Just like a negative charge isn't attracted to a negative side of a battery. A north pole of a compass emits lines pointing away from it. The north pole of a magnet pushes north sides of compass away from it. So a compass will point towards the south pole of a magnet. It is attracted to the south side of the magnet. If we say the compass needle points in the direction of the field and opposites attract, then the field points away from norths toward souths, toward the south side of a magnet. Yeah? You should know. Do you know? Does everybody know compasses are little bitty magnets? That's all a compass is. It's a little tiny itsy bitsy piece of metal that's magnetized that can float freely and turn in any direction. Did you all know that? Compasses are magnets. So the compass needle is a little magnet. It's got a north side and a south side. And if you hold it up next to a south pole, the north side of the compass, the magnet that is the compass, is attracted to the south pole of the magnet. Yeah? Because opposites attract in electricity and magnetism. Tell me this, what's Santa Claus got? Does Santa Claus have a North Pole or does Santa Claus have a South Pole? He lives at the North Pole. Does that mean it's a magnetic North Pole? Google Form A. What do you think? Does Santa Claus have a North Pole or a South Pole magnetically? The Earth is a big magnet. Santa Claus lives in the Arctic Ocean, by the way, the opposite side of the penguins, which is a new fact if you're the president. I mean, yeah, or you can just read. Let's see how many people read or think. The equator is not north. The equator is not a North Pole. The equator is not a South Pole. And magnets do not point towards equators. Compasses do not point towards equators. North Pole of the Earth is in the Arctic Circle, near Alaska, sort of, kind of, a bit, North Canada. And Antarctica is the South Geographic Pole of the Earth. That's the other magnetic end of the Earth. So no, it's not the equator. Okay, again, Santa lives on the opposite end of the planet from penguins. Santa Claus is with Alaska and North Canada and all that. If a north side of a compass is attracted towards Santa Claus, what does Santa Claus magnetically live in? He's the South Pole. I mean, cough, cough. Hint, hint. I said that. That's what he said. Okay, so Google question A. Again, the logic here is magnets point, compasses point in the direction that they think is north. And since opposites attract, the north side of the planet, the top of the planet that attracts north sides of compasses is a magnetic south. Turn to your neighbor and express this idea. Why do opposites attract mean that the North Pole is magnetically south? Ready, set, go. Turn to each other, really.
As you said, like the magnet field, uh, you know, comes out of the North Pole and goes back into the South Pole. So even on Earth, is that like
Even what?
even on Earth
Yeah.
like that?
Yeah.
Okay. So
So if you actually stand exactly on the top of the South Pole or North magnetic pole, points up and down. The compass points up down. What? Say that again?
Whatever's pointing, and would be magnetic south. I mean, magnetic west.
If your arrow points that away, then there's a south magnetic side here or north magnetic side here.
Still
Which way the Earth is shows the Earth's magnetic field. If you overwhelm a magnet by putting it near a strong magnet, it doesn't have to be that strong. You can easily do that. That doesn't make the Earth turn, right? But we could say this end of the magnet is this way, that way, or the other way. We don't have east poles or west poles. There is no such thing as a magnetic east or west. Okay, ask me a question. Yes, please, for everyone. Shh, listen to her. South of any magnet is attracted to north of any magnet. The north side of the compass is defined as the side of the compass that points towards Alaska, Antarctica, whatever. No, the Arctic circle. Since we want to say north is up on a map and opposites attract, that means that there is a south side of the magnet that is the Earth up on top of the map. But any magnet and any compass, which is a magnet, the opposite sides of the magnet want to attract each other. And the same side of the magnet and the compass will repel each other. Please, Fernando.
is south negative?
No, we do not talk about plus and minus. No. If you have a minus north, we'll talk about that. Minus north is south, but we don't call north plus and south minus. You can have a negative. You can flip a direction, as we'll see in a bit. You could flip a direction, but we don't say south is negative. There is nothing electrically negative. Electricity and magnetism, completely different topics for now. So there are two electrical signs, plus and minus. There are two magnetic signs, north and south, and neither of the twain shall meet. More questions? Major takeaways here. Thou shalt know this, or thou shalt learn. I define the direction of the magnetic field by saying, if I hold up a compass, which way will the north end of the compass point? Major point 2, opposites attract. Duh, right? North attracts south, north repels north, south repels south. We can deduce from this that the magnetic field direction on Earth points southward. If the magnetic field direction points northward, that means the north end of the Earth is a south magnet end. We replaced the Earth, we took away the Earth's internal currents that make its magnetic field and put a giant freaking bar magnet up. We'd have to put the south end up in the North Pole and the north end down in the South Pole for compasses to point the same way. I want to mention here, this isn't as important, but you need to have a feeling for this. The Earth's magnetic field is weak. 50 millionths of a Tesla. That's not that hard. That's not that strong. We easily overwhelm this. I have built personally in my garage a magnet 10,000 times strong, 20,000 times stronger than this. Something on the order of a tenth of a Tesla. It's not that hard even. Took some big fat wire and a car battery, but there's nothing to it. It's not sophisticated. You can easily overwhelm the Earth by a factor of 10,000. The thing that the Earth has that your magnet, electromagnet or bar magnet doesn't is it's astronomically large. There is a lot of magnetism in the Earth. It's weak, but that's because it's spread out over a huge volume of space. Details. Major point two, no. Earth's magnetic field on the order of 50 microtesla. Please note, if there's a homework problem that gives you, I want you to know, 4 tests, 4 quizzes, whatever, the Earth's magnetic field is small. Get this order of magnitude stuck in your head. This is not precise. It's actually 52 point something and varies a little bit based on where you are. If there's a homework question where the text gives you B on Earth is 52 microtesla, use what it tells you. Its answer will be expecting that, yeah? Yeah. Yes, magnetism and gravity are very different things. I am not gravitationally attracted to a magnet.
Depends on where you are. So
yep, 2 things can depend on where you are. Just because, just because 2 things have the same quality doesn't mean they're the same thing. Okay, so it's not up down for what it's worth. So it's not whether you're high altitude or low altitude. It's your distance. Actually, it does vary with altitude as well, but your closeness to the poles. Details. Hey, Google Form B, which direction does a compass point? Does it point with the magnetic field direction, against the magnetic field direction, or at right angles to the magnetic field direction? Chop. Which direction does the compass point? With, against, or at right angles? Chop, quick. Again, does the compass point in the same direction, opposite direction, or at right angles to a magnetic field? Is the Google B. Okay, let me go back to the previous slide. A magnetic field shows which way the compass points. The north pole of the compass is the direction of the compass. If you look at the direction the compass points, that defines the direction of the magnetic field. So if I tell you that a field shows which way a compass points, and then I ask you which way does a compass point, what's the answer? With. If a compass points in the direction of the field, and I ask you which direction does the field point, the answer is the compass. Okay, most people, 80% of you said against. The fact that Santa has a south magnetic pole and the definition of direction of magnetic field are different things. I think most people took away the top of the map is the south pole, south side of a magnet, and thought that that means that the south direction is north. No. Read the slide. Read the top point. Turn to each other, read the slide. Now read the question. A compass points which way? With the field, by definition. Yeah? You see it? That's all you need to know about fields for now. We'll talk about how to calculate magnitudes later. For now, I just want you to understand a direction. So far, so good? No for 80% of you? No far, so good? Well, here, we're going to start again. Here's a new thing. How much force, if I tell you a magnetic field, how can I calculate how much force it exerts? North, Gina, north. North pole of a compass is the direction of the compass. That is the needle, that is the marked needle in a compass needle. And I define magnetic field direction to be which way a compass points. Okay, hey, by the way, who has never had an opportunity to play with a compass? Never played around with a compass and bar magnet? Okay, a fair number of people have never touched a compass and bar magnet before. No. Different people have different experiences. You have homework. Y'all are in lab here, yeah? Go to your lab instructor and tell them, especially if they're me, hi, Mr. Handsome Lab Instructor, give me a compass and bar magnet right now. This week we're finishing a lab on circuits, on electricity, current, but there are compasses and bar magnets in the lab supply room. I literally want you, here's your homework, spend 5 freaking minutes playing with the bar magnets and the compasses. Figure out which direction, which side of the bar magnet is north and which side is south. Find out whether north opposes north and south opposes south. Yeah. A compass shows something else's magnetic field. A compass is a really freaking weak magnet. It does make its own magnetic field, but it's very tiny. You're never going to measure that. So a compass tastes, the compass reacts to something else's field.
South magnetic field of Earth.
Yes. I mean, unless you bring in another big honking bar magnet. Yeah. Harsh.
That is like, what if we place a bar magnet near the compass, which so
The North Pole will be attracted to the south side of the bar magnet. Opposites attract. No, the North Pole of the compass, the north side of the compass. The compass will point, the north side of the compass pointing direction points towards souths. North attracts south.
that is not the question.
No.
Does the compass get influenced by the bar magnet or the
Yes.
Earth's magnetic field?
Well, both, but the bar magnet's going to overpower them.
Yeah, because it's weak.
Yes, exactly. That's my point in saying it's so weak. 50 millionths of a Tesla, small number. Bar magnet, big number. Yeah. Yes. Can the what? Yeah, sure. Why not? Every compass feels the field it's subjected to. Great. So if I tell you which way a compass points somewhere, you'd better be able to tell me which direction the field points. If I tell you that I've got a south pole of a magnet somewhere, you should know that a compass will point towards it. If I give you a north pole of a bar magnet somewhere, you should know that the north pole, a compass will point away from a north pole, a north side of a bar magnet. Now let's say if I tell you the magnetic field, which we call B for unknown reasons, terrible reasons, hideous eldritch reasons, magnetic field B, if I give you a number and a direction, you need to be able to calculate how it pushes and pulls on things. Okay, here's the terrible fact. There is no magnetic charge. There is no free norths, free souths. So there is no thing which is pushed north or south by the north and south field lines. Here's the connection with electricity. Electrical charges feel magnetism if, write this down, they are moving. A magnetic field exerts a force on a charge, electric charge, if that electric charge is moving. Anywhere. If it is not staying in place on that charge. Yes, yes, yes. No matter what, if you got an electron sitting here, staying here, not moving, no effect from the magnetic field, no matter how big the magnetic field is. As soon as that starts to move, if it's flowing inside a wire, if it's just shot through outer space, a moving charge can feel forces from a magnetic field, moving electric charge. And there is no such thing as a magnetic charge. No one's ever observed an isolated north particle.
A magnetic field exerts a force on the charge.
If it's moving. A stationary, this is something to know. If velocity is zero, magnetic force is always zero. It's like velociraptors in Jurassic Park. If you don't move, they can't see you. Has everyone been subjected to that? You know what I'm talking about? Okay. Now, there are two parts of force. What are they? There are two things to know about force. What are they? A force has a what? Magnitude and direction. Muy bien. The magnitude of a magnetic force that I'm going to give you is a really very simple formula. The direction is more complicated than you've ever seen before. Don't go to sleep. I'm going to let you go early if and when you get this. Here we go. Here's the formula. Charge, velocity, field. Multiply them together, profit. Write it down. Q is the charge of a particle. V is its, well, in this case, its speed. And B is magnetic field. Well, the velocity has a direction. And the magnetic field also has a direction. How do you multiply two things with a direction together?
Cross product or not?
It is the cross product. You know about cross products? This is correctly written Q times velocity cross magnetic field. That's the vector expression. Most of your classmates have never heard of cross and dot.
So, vectors cannot like multiply.
Well, there are two kinds of multiplication, and I didn't know you had heard about them. I didn't know that you knew what cross products were. This is a cross product, B cross B. Yeah. Okay, now, muy importante. There are a couple of words on the slide that you actually have to pay attention to. What do I say? A charge moving at what? Read the next words. A charge moving at right angles. If velocity is crossing field, then there's a force. If force is moving along a field line, if the force is moving in the direction that a compass says is north or the direction opposite that, how much force does it get? Google form C. A charged particle of charge 1 coulomb is moving at 1 meter per second, straight north in a 1 Tesla magnetic field. Tell me the force. Again, Google form C. If Q is 1 and V is 1 and B is 1, and the direction is northward, what did I just say about the force it feels? I'm getting wrong answers. I'm getting a lot of wrong answers. Hint, if you read the board, it'll tell you the answer. One more time. If Q, V, and B are all 1, and the velocity of the particle is facing northward, what is the magnitude of the force that field exerts? The magnitude, the amount, the number, not the angle, please. I have people telling me the magnitude is right angle. Magnitude means number. Come on, people, read the slide. What did I just say here? Okay, please turn to your neighbor and read the slide out loud. That is too many red answers. Read aloud to each other and think briefly what words you have just said out of your mouth. Newton's. Force is force is force. Yes. What? So? So if you multiply Q times B, that is what is necessary to accelerate 1 kilogram at 1 meter per second squared. Sure.
Exact question I was like, thinking at this, I didn't hear you.
If Q, V, and B are all 1,
Like back in.
yes, a charge moving northward experiences what field? What force? If Q, V, and B are all 1, and the charge is moving northward, what is the force? Okay, you may amend your answers if you like to see. Give me some hope, people. Nope. Okay, let's try this again. The force on a charge moving in the direction that the field points is 0. A charged particle, which is moving north or south, does not feel a force from the Earth's magnetic field. If your charge is going north, if your charge is going south, Earth does not push on it. The magnetic field does not show the direction of the push. The first few words here, a charge moving at right angles, 90 degrees from a field gets QVB. If you're not moving at right angles to the field, you are not getting the full QVB. Google form, let me try a question again. Suppose you have a charge of -1 Coulomb moving at 1 meter per second south in a magnetic field which points straight south. Okay, again, Q is -1 Coulomb, V is 1 meter per second, B is 1 Tesla south. Can you find the magnitude, not direction yet, of the force? This is Google question D. Q is -1, V is 1, B is -1. And the velocity and the B field are directly south. Turn to each other and tell each other the words that just came out of my mouth a minute ago, by the way. Okay, I'm looking for a number. Now, magnitude is a number. Do not tell me south. That's not what magnitude means. If I tell you how many dollars did you earn and you tell me south, that's not sane. We have 20% of the class not hearing the words that you are saying out of your mouth or the words that are coming out of my mouth. Shh. Think. This is not supposed to be the hard part. If you go north or south in a field that points north or south, it says here the force is 0. If you go along a field line in the direction of the field, if you are holding a compass and it says north is that way and you go that way, that magnet can't push on you. One more Google form. Q is 1, V is 1, B is 1. And both the field and the velocity are pointing west. So if you move westward in a westward pointing magnetic field, you are evidently holding up a bar magnet to overcome the Earth's magnetic field. Field points west, your velocity points west. Q, V, and B are all 1. What is the magnitude of the force? If you still get this wrong, I'm going to simply unhighlight you and give up on you. For today, anyway. No, this has to do with the fact of... Please. Okay, help each other out real fast. You got one last chance to fix it. One chance to be able to read words. Harsh.
Solve with this, PV sine theta.
Yes.
Then.
Sine of 0 is 0.
it
Exactly.
makes it really,
Yes.
I'll say because.
If you know what sine means.
Yeah, in the last question, you said like the martingale is going opposite to the,
Yeah.
so it's like sine 180,
Yeah.
and then that's.
0. Exactly.
So that's correct, right?
That is absolutely correct, but 90%, 60% of the class will absolutely riot if I introduce trig.
No, but like,
That is correct. 100% correct. If you know what sine is, then yes. Okay, so I am simply going to ignore, if you have ignored each other, your own words, and me 3 times, I'm sorry, but I'm giving up on you. 80% of the class is apparently listening, so let's move on. The correct answer is, for the 4th time, 0. Let's move on. The direction of the magnetic force is not in the direction of motion. The direction of magnetic force is not in the direction of field. If you are moving up and field points north, neither of those are the direction that the field pushes. Okay, so if it's not north or south, if it's not up or down, what's left? The force will be either east or west. Again, if you have a field pointing left, right, and you have a velocity which is up, down, if you have a field pointing left or right, a field which is pointing up or down, and I say that it is neither of those directions, it is not up, down, it is not left, right, what does that leave? The axis that is at right angles to both of these axes. It is neither up, nor is it left, nor is it right, nor is it down. Which way is the 3rd dimension? South. I don't know which way north and south are in this room. Horizontally, this way or that way. Yeah, exactly. As it happens, I think that's the north side of the room, I think. Is it? Okay. Oh, it is. Okay. Wrong. He's wrong, not me. Great. North is that way. When I say left, right, and when I say north, south, east, west, I mean different. I'm not necessarily talking about this room, by the way. So for all y'all, that way is north, okay? Let's establish that as true. You guys don't have to refer to that as away. You guys don't have to refer to that as towards. You guys don't have to refer to that as right. If we're talking about towards, away, left, right, we're not also talking about north, south, east, west. On the other hand, if I give you a map and I show you a charged particle is moving north in a westward pointing field, then the correct answer is not left. It would be up, as the case is. Okay, so my point is, and I do have one, I'm going to tell you about directions in a second. You must also know your left from your right. You must also, here are the answers. You know your left from your right. You must know which direction north, east, south, and west are. You do not need to know, let me say this way. You do not need to know which direction north actually is. You do not need to be oriented on, oh, I'm pointing north now. I'm pointing north now. But you do need to know that if north is this way, that way is, for God's sake, from your perspective, that's east, right? Yeah? Okay, so you need to be able to draw a compass rose, yeah? Never eat shredded wheat. Never eat soggy waffles, whatever. Any SW pointing clockwise. If you don't know your left and your right, if you don't know your north and your south, on your paper right now, write them out. We're going to be doing some exercises, and a fair number of people are struggling with keeping track of this in the 3 o'clock section. Okay, so on your paper, left, right, check with your neighbor, northeast, southwest, be able to draw that compass rose. There are 2 methods of drawing directions on a piece of paper. Northeast, southwest, up, down. If you recognize which way, if you pick a direction for north, east is always at the same orientation with respect to that. But on paper, we've got to be a little more precise. Hey, which way is this on a piece of paper? If you're holding a piece of paper out in front of you, which side is that? That's rightward. Duh, yeah. Which way is that on a piece of paper? Left. You could just look at the projection screen. Imagine it's a book. Which way is that on a piece of paper? Duh, right? Which way would you call this? This direction. Forward, out of page. There are lots of possible answers. I'm going to say that the convention in physics and mathematics is to call this direction out of page. If it is pointing toward you, we call that out. Which direction do you think this is? In. We are talking always relative to the piece of paper. You know, like if I'm looking at my own nose, I'm pointing in towards my nose, yeah? Ow. This is not in direction. This is not in. I imagine I'm holding a book or a piece of paper. What is happening with that direction relative to the piece of paper? That's out of the plane of the paper towards me. So don't think about yourself. Stop thinking about yourself so much. Let's draw in and out on a piece of paper. This direction I call up. This direction I call down. This direction, I hope you will all agree, are right and left. In and out. Can anyone draw me a piece of, a little bit of ink that sticks out of the page? Anyone have a pencil that can do that? Yeah, I wish. It'd make teaching magnetism a lot easier. There is a convention. Out is a dot, in is a cross, an X. I like to circle the dot and the cross, but you won't see it in the homework system. So I'll probably do it when I'm writing absent-mindedly. I like to circle it because it makes it, it emphasizes it, draws your eye to it. But, dot, out, cross, in. Here's how to remember it. If I stand behind the screen and shoot an arrow out of the page coming at you, it's coming out of the page. What do you see from the arrow? Just before you die. You see the dot of the arrow, right? Now you shoot the arrow at me. I stand behind the whiteboard. You shoot it into the page. What do you see before I die? You see the feathers, the fletching, the stuff on the back of the arrow that makes an X shape, yeah? Alrighty. This is our coordinate system. Now I'm going to tell you the right-hand rule. I'm going to lay down the law to you. If you can get this, you get to go. Fast. Hold out your right hand, extend your fingers stiffly, extend your thumb stiffly. Now don't change this. I had a whole bunch of people in the 3 o'clock class that were doing this, and your thumb and your fingers are no longer perpendicular to each other, and they're no longer perpendicular to your palm. You got to keep your fingers rigid, okay? Okay. Now, the next trick is, once you point in a direction, you can't change that direction. If I point towards the door, and then I say the second direction is towards the back of the classroom, I can't move which finger, the finger that's pointing towards the door, to be towards the back. You point your first finger, well, all of your fingers, in the direction of whatever I say the first vector is. You point your palm in the direction of the second direction, the second vector. Your thumb shows the answer. Okay, and the formula that we're going to do here, I want you just to concentrate on V cross B for a second. Cross means find the right-hand rule for. So we're going to say if a particle moves towards the door in a magnetic field that points out of the page, can you all deduce which direction it is pushed? Ready, set, go. Use what I've just taught you. Google form. Google form F. Yes, if a particle, charged particle, use this rule. If a charged particle has a velocity to the left in a magnetic field which points to the back of the room, this way is left. The doorway is left. People who are sitting sideways, yeah. This way is left. That way is the back of the room. If your velocity is that way and the magnetic field points that way, which direction is the force on the particle? Ready, set, go. I do this too. I like this too.
What-
People tend to do this, in my experience. They make,
So, like, why did scientists do this?
there are many ways you can hold body parts.
Meaning, to the back.
Force is back or field is back. I did. That's the second vector. Yes, for now. Yeah, we're going to introduce how to find the direction of field later. That'll also use right-hand rule. Okay, so everyone hold up your hand. Your hand should be parallel to the hand on the board. Look, my fingers are pointing towards the door. My palm is pointing towards the back of the room. Miriam, I'm sorry, I asked this already 3 times. I am pointing to the door side of the classroom. My palm is pointing to the back of the back of the classroom. Which way is my thumb pointing? The force is up. I would express this mathematically. I would express this in a problem as saying what? This is left cross out equals up. Yes, Gina. Okay, let's do a million practice problems. I mean, you can't just let this stuff wash over you. You're not going to get it. Oh, this is 10% of your midterm, by the way. If you can find your left and your right and your north and your south and east and west, and remember 1, 2, 3, there's 10% of your midterm right there. If you ignore this, you're screwed. You can't get an A. So let's calculate a bunch. Down cross, no, I'll do that later. Down cross left, up cross into page, right cross into page, left cross down, down cross right, up cross out. And we'll put these on the Google form. And I will remind you in 2 seconds. So we're at G, H, I, J, K, and L. Again, I will remind you, here's how to do it. Your fingers are the first. Your palm is the second. Keep your hand rigid. And as you point in one direction or the other, if I'm pointing with my fingers up, I cannot then point with my fingers back. I cannot point with my fingers to the left. I point with my palm to the left, my palm to the back, my palm this way, that way, the other way. If your fingers are going in a direction, you cannot turn your arm. You have to rotate your wrist. Okay? Find the first direction, point that way with your fingers. Rotate your palm to face in the second direction. Rotate your arm once your fingers are set in a given direction. Stick that thumb out.
The first direction is the finger, the second direction
Thumb.
is the.
There are many ways to do this. I do it with 1 cross 2 equals 3.
Yeah, from the force.
Yes,
Yeah,
you said
so
fingers.
force
Yep.
down is this, and left is this one.
Mm-hmm.
That's good.
Correct. What would you call that answer?
Do the
Good. Perfect. You have a huge advantage having done cross products before. Massive advantage. Do you know the standard orientation of the z-axis in a coordinate plane? If this is x and this is y, do you know which way z points? This way.
into this exact
If that's x,
into and out of the thing.
yes, but which way is positive z? Into or out of? Which way is positive z? Into or out of? You remember? Have you done this?
Must be into that. Nope.
The mathematical convention is out. And you can calculate that by saying x cross y is z.
Okay, there must be a positive of the axis and negative of the axis.
Negative is that one. Yeah, if that's x, then that's y. That's it.
Y, the positive x, y, then the positive z should be into the.
It goes with the right hand rule in order. First vector, x. Second vector, y. Third vector, x cross y is z. Question me. Oh, you're just holding up your hand. You're not asking. Oh, you are asking. Okay. Question me. Huh? Well, if I say down cross left, first point down. If I say the second is cross left, then thumb left. Up, palm left. Yeah, what would you call that? That's not a way.
Facing down the paper.
Good, perfect. Down cross left is in. Yeah.
This way.
Well, hold on. You're doing something which I did not show you.
Yeah, this.
Yeah, not this, not this.
Okay.
Yeah.
That's showing this.
Yeah, what do you want? What do you want to do? Give me an example. Pick two directions.
Down.
Down, cross, right. What do you think it is? Show me your hand.
So my hand is down. Right?
No, your fingers come first. Your palm comes second. Your thumb is the answer. So point your fingers down. Now point your palm right. That's your left. That's your right. Which way is your thumb pointing?
And it's right down.
What?
If it's right down.
Show me right cross down. Show me your hand with the fingers pointing right.
So the orientation of the
Right cross down is opposite of down cross right. That's correct. Yes, always.
So I greatly, pulling up the compass and see what direction was showing. It was still showing the north was in the same direction always.
The magnet in the iPad is an incredibly weak magnet. Wait, which magnet are you talking about? The one that the internal compass? You're talking about the magnet on the flap? Okay,
And with the bodies.
to hold the stuff, hold the cover.
Yeah, like this.
Yeah. I think that's the pencil. Whatever, doesn't matter. Yes, those are weak, but you should be able to feel them. I would imagine you'd be able to feel them, measure them with the phone sensor. You can't?
Look like
Well, you need to stay after. It's time to. Okay, everybody, let's pull it together. Shh. Pull it together. I want to see all of your hands, every one of your hands, all of your hands. Everyone put your hand in this orientation. You could do it relative to yourself. Y'all and y'all don't need to point in the same direction as they are. I'm going to point in direction that they are for the sake of it. Okay, so fingers ready. Which side of your hand points in the first direction? Your fingers. Everybody point your fingers down. Shoink. Everybody agrees on the downward direction. Point your fingers of your right hand downward. Okay, now what's the second direction? Is it your thumb or is it your palm? Palm. Does your palm point left or does your palm point right? So do that. Orient your palm pointing to the left of the class. Which way does your thumb point now? Think of the paper. Into the paper. Down cross left is in. Hold your fingers down. Whoopsie. Show your neighbor. Show your neighbor. Prove it. Down, cross, left is in. Out. In. No, in. Oh, God's sake. I can't do this without actually doing it. Yeah, question. I don't have a choice. It's either camera or whiteboard screen. And at this point, I'm going to point out that this is not a hybrid class, and that I've been telling all y'all the entire darn semester that if you don't come to class, you're going to be missing out. So sorry, but if you stayed at home without actually physically being sick, that's on you. Not to be strict or anything, but like I've been saying it all semester, actually all year. All right. Next one. Up. What side of your hand goes up? I promise to point up. Okay, what's the second side of your hand that you use? In towards what? Into the paper. What's up, cross in? Left. Yeah, up, cross in is left. Everyone hold your hands up, do this. Help each other. This is really hard until it clicks, and then it's trivial. Trivial, although I will admit, I always have to do it every time. In and out R180. Questions? Anybody? Yes, please. Well, Jay, well, from your perspective, right now you're pointing to your left with your fingers. Well, hold on. Your fingers are pointing left regardless of how your thumb is pointing. You need to do the second vector. Hold your fingers in the same sense and rotate your wrist till your palm is down. That is your palm is towards you. That is your palm is down. So which direction moves your thumb? What would you say the answer is? Yes, which is called? Correct, out of page. Okay, check it yourself. That's what she said, and she's right. Okay, everyone, fingers left. Palm down. And which way do we call thumb direction? We call it ow, as in ow, I'm poking my own eye out. No, that's up. You were holding your fingers up. Your fingers do not go up. Your fingers go to your left. That away. That is to your left. Fingers left, now palm down. Face your palm horizontally down. That's showing left cross down is out. Down cross right. Which way is down cross right? How do you hold your hand? Down. Fingers go down. Cross right. Which way is right? Check your paper if you need to. That's right. Thumb. What do we call this? We call this the out direction. Let's do the last. Up, cross out. Up, cross out is right. And right, cross in. Put your palm in. Your palm faces the board. No, your palm is facing you. Don't think of you. Don't think of yourself. Think of the board. That's in. Which way? Yep, up. Now, do you want tricks? Do you want to avoid doing work? I like avoiding doing work. It's easy once it clicks. Hard for a lot of people at the beginning. Okay, here are some tricks. Ready? Take a look at a pattern. Down cross left, down cross right. What do you know about the result? Opposites. Rule 1. If you flip one of the vector directions, it flips the answer. Rule 2. Did I remember to do this? Yeah, right. Left cross down, down cross left. What do you notice about their answers? Opposites. In and out are not the same direction. Okay, so left cross down and down cross left are opposites. Muy importante, which comes first and which comes second? The answer flips. If you flip which vector is first and which is second, you will flip the answer. Right cross up cross right, different directions. Third thing is something that I didn't make explicit here. Everyone take out your hand. Keep it rigid, okay? I want you to point your fingers to the right and your palm to the right. No, keep your fingers right. No, put your palm to the right. No, why aren't your fingers and your palm both right? All you have to do is put two perpendicular directions parallel. Geez, can't you do that? Can you put two perpendicular lines parallel to each other? Then right cross right will always be 0. Left cross left will be 0. North cross north will be 0. What is the force on a particle moving north in the Earth's magnetic field? 0, because velocity is 0. Velocity is in the same direction as magnetic field. North cross north is 0. Okay, so third rule, parallel directions or anti-parallel, north cross south. Can you put your fingers pointing north and your palm pointing south, like while keeping it right angles? No, that's not worky. So parallel or anti-parallel, the cross product is 0. Not south, not north, not east, not west. The last thing is I want you to notice the axes. Left, right, up, down, in, out. Left, right, in, out, up, down, in, out, left, right, down, up, left, right, in, out. Did I ever repeat myself with the axes? Right? I never repeated myself. The answer is never parallel to one of the incident axes. I'm going to ask you questions on the test. As I said, 10% of your midterm grade is based on if you can track your left and your right and your up and your down. 10% of it is this. You got a 50% chance of getting it right if you just eliminate parallel answers. If I've got up cross out and I don't know anything, I can rule out up and out as the answer. I can rule out down and in as the answer. Okay? So everyone had better, at the very least, be able to rule those out for the test. It is never parallel. No, not this, this. She gave me a thumbs up with her hand. Thumbs up, go like this now. Okay. Those are the 3 rules. Last, if you know which direction north is, great, use it. If you know which way north is, north is the right side of the classroom, great, use it. However, problems with north, east, south, west, if I give you problems, and I will give you problems with north, east, south, west, up and down as directions, you don't have to know which way is actually north. Just imagine some direction is north. If you imagine this way is north, you're wrong. But if you calculate a cross product as that way, what are you going to say? If this is north, what way is that? East. If that way is north, you're going to calculate that way as the cross product. The relative orientation of north and east is not changed if you get the compass direction wrong, okay? So, to do any problem at all, we're asked about northeast, southwest, pick a direction to be north. Imagine a compass, northeast, southwest around you, and do your problem relative to that. By the way, if I see people saying north cross west is in, that's just silly. North, south, east, west, up, down are what you get with a compass, right? In, out of what? Don't mix up. We've got 2 coordinate systems. They both have up, down. But if you see up and left, can the answer possibly be northeast, southwest? Up and left. Left which way? Left has to be relative to a piece of paper. Yeah? So, don't confuse the coordinate systems. If I'm talking about north, south, east, west, use north, south, east, west. If I'm talking about up, down, left, right, in, out, use up, down, left, right, in, out. is good, is happy. If Q is negative, answer flips. We'll do that next time. First, I want you to get good at right angle. First, I want you to get good at doing cross products. Oh, this multiplication, by the way, this is the correct mathematical symbol. This is called cross. We'll talk about that later. Actually, we won't. Okay, you're done. Merry Christmas. Go early. You can come up and ask questions if you like.